consider the complex number z, which is equal to cosine of theta plus I sine of theta. Question A, use the Maths theorem to show that z to the power n plus z to the power negative n is equal to 2 times cosine of n theta. The Maths theorem says that for a complex number z, which is equal to r multiplied by cosine of theta plus I sine of theta, z to the power of n is equal to r to the power n multiplied by cosine of n theta plus I sine of n theta. Formula is given in a data booklet. So here we get that z to the power n plus z to negative n is equal to, just using this formula, i.e. its modulus is equal to 1 here. So it's just cosine of n theta plus I sine of n theta plus cosine of negative n theta, just substituting negative n for n, plus I sine of negative n theta, cosine of n theta plus I sine of n theta. But cosine is even function. Cosine of negative x is equal to cosine of x, so it's just cosine of n theta. But sine is odd function. Sine of negative x is negative sine of x, so it's minus I sine of n theta. And we can see that sine cancels, so we get 2 times cosine of n theta as required. Question B, expand z plus z to negative 1 to the power of 4. Let's write Pascal's triangle firstly. It looks like this: 1 1 2 1 1 3 3 1 1 6 4 4 1 1 10 10 5 5 1 1 20 15 6 15 6 1 1. It's 4, power of 4 and power of 6. So z plus z to negative 1 to the power of 4 becomes coefficient. Actually, you may use combinations instead of using Pascal's triangle. It doesn't matter, so it becomes power 4 coefficient 1 and z to negative 1. Let it be to the power of 4, this to the power of 0, and it's just usual binomial expansion. Then coefficient, this exponent decreases by 1, this increases by 1, so it's z cubed, actually z to the power 4, z to negative 1 to the power of 0, plus 4z cubed, z to negative 1 to the power of 1, plus 6z to the power of 2, z to negative 1 to the power of 2, plus 4 z to the power of 1, z to negative 1 to the power of 3, and plus 1 z to the power of 0, z to negative 1 to the power of 4. And let's simplify it. So it's just z to the power of 4 plus 4z squared plus 6 plus 4z to negative 2 and plus z to negative 4. So it's the required expansion. Then C shows that cosine to the power of 4 is equal to this. So let's consider z plus z to negative 1 and actually using the same formula. It's what? It's 2 multiplied by cosine over 1 theta, so it's just 2 times cosine of theta and to the power of 4. So we just use this formula for this. It's 2 times cosine of 1 theta, but then to the power of 4. But on the other hand, using expansion, this is equal to this, and this plus this, it's what? The same formula for n is 4. So it's 2 times cosine of 4 theta plus this plus this. But you can see that 4, it's a common factor, so it becomes 4 times this, and n is 2. So it's 4 times 2 times cosine of 2 theta, and plus just 6. And then cosine to the power of 4 of theta, just divide each term by 2 to the power of 4, which is 16. So it becomes 1 over 8 cosine of 4 theta plus 1 over 2 cosine of 2 theta plus 6 over 16 or 3 over 8. Let's check. Correct. Then D shows that cosine to the power of 6 is equal to. So let's do the same, but for the power of 6. So I will write it again to avoid mistakes, but if you can guess, you may write directly. So z plus z to negative 1 to the power of 6, it is equal to expansion. Coefficients are here. So it's it becomes 1 z to the power of 6 plus z to the power of 6 plus 6 z to the power of 5 and z to negative 1 plus 15 plus 15 plus 15 z to the power of 4 z to negative 1 and squared plus 20 plus 15 here it's z 20 z to the power of 3 and z to negative 1 also to the power of 3, so it's just a constant term, and plus 15 z to the power of 2 z to negative 1 to the power of 4 and plus 6 z to the power 1 z to negative 1 to the power of 5 and plus z to negative 6, and it becomes z to the power of 6 plus 6 z to the power of 4 plus 15 z squared plus 20 plus 15 z to negative 2 plus 6 z to negative 4 and plus z to negative 6. So z plus z to negative 1, it's 2 times cosine of just theta to the power of 6, or 2 to the power of 6 cosine to the power of 6, and is equal to, it's what? It's 2 times cosine of 6 theta plus this 6 as a common factor times 2 cosine of 4 theta plus 15 times 2 times cosine of 2 theta and plus 20. And we need just cosine. So cosine to the power of 6 of theta becomes 2 to the power of 6, it's what, 64, so it's 1 over 32 cosine of 6 theta plus it's 6 over 32 or 3 over 16. Yes, 3 over 16 cosine of 4 theta plus it's 15 over 32 cosine of 2 theta and plus 20 over 64, which is 5 over 16. Hence, find the value of this integral from 0 to pi over 2. It's paper 1 without a calculator. Cosine to the power of 6. So just using this, and you can notice that cosine, integral of cosine, it's sine of 6 theta and something. But since limits are from 0 to 2 pi over 2, and if you substitute limits, you get 6 times pi over 2, it's 3 pi and sine of 0. So you get points somewhere here, and you can notice that for other cosine, you can see that you will get sine of 4 theta, and it becomes 4 times pi over 2, it's 2 pi, and also 0, 2 pi, it's pi. So you will get that limits are points somewhere here, and sine is 0 for all these values. So the only non-zero term will be here. So it will be just 0, integral from 0 to pi over 2 of 5 over 16 d theta. And it becomes just 5 theta over 16, and limits, it's quite clear that it just 5 over 16 multiplied by pi over 2, or 5 pi over 32. The next. The region S is bounded by the curve y is sine of x multiplied by cosine squared of x, and the x-axis between x is 0 and x is pi over 2. Question F. S is rotated through 2 pi radians about the x-axis. Find the value of the volume generated. So volume generated, it's 2 pi integral limits from 0 to pi over 2 and function squared, so sine squared of x cosine to the power of 4 of x dx. And how to integrate this? Sine squared, it's it's 1 minus cosine squared, so it becomes 2 pi integral, and 1 minus cosine squared, so it's cosine to the power of 4 minus cosine to the power of 6. And it's 2 pi, and integral for cosine to the power of 4 to the power of 6 is already calculated, and we need just calculate to the power of 4. But using the same reasoning, if you integrate this, you will get 0s, but only integral for this constant term, it will be the only non-zero term. So, and where is to the power of 4? This. So constant term is 3 over 8. 3 over 8. Hence it becomes 3 over 8 x and limit, so just multiplied by pi over 2, or 3 pi over 16 minus the previous result. It's 5 pi over 32. 5 pi over 32, and it's what, 6 over 32, so it's 2 pi, 1 pi over 32, so it's pi squared over 16. Oh, 32. Pi squared over 32. Let's check. 32, 6 minus 5, 2 pi, 1 pi over 32. Okay, the next. Write down an expression for the constant term in the expansion of z plus z to -1 to the power of 2k. Hence determine an expression for this integral. So let's see for this. For example, for power of 4, if 4 it's 2k, in general you can see that it's a 0, 1, 2, and 2 it's just half of 4, so it's 4k. There is a constant term. And what is constant term in terms of combinations? It's a combination 0, 1, 2, 2 out of 4, and in general it becomes combinations what, k out of 2k. So constant term becomes combinations k out of 2k, and just using formula for combinations, it's what, greater factorial and smaller factorial, and greater minus smaller factorial, which is just k factorial. And finally, hence determine an expression for this in terms of k. So in general, so now we consider this to the power of 2k, and let's see here, you can see that on the left hand side you get, if it's in general to the power of 2k, you get 2 to the power of 2k cosine to the power 2k of theta is equal to, again, all zeros up except constant term, and constant term is this. Constant something, cosine of what, even arguments, and plus constant term. So finally this integral becomes, notice that we consider cosine of cosine to the power of 2k only, so it becomes 1 over 2 to the power of 2k, and something cosine, and all cosines give us zeros, because we get integral of sine, but sine of even argument, and if you substitute 0 and pi over 2, you will get that limits are equal to sine of at these points. So there will be zeros, except constant term, and constant term is this 2k k factorial to k factorial, and just integral of constant term d theta, which is just constant term times theta, and substituting limits, we get that it's just a constant 2k factorial divided by k factorial, and this 2 to the power of 2k and multiplied by pi over 2. Hence, finally, it's pi multiplied by 2k factorial divided by 2 to the power of 2k plus 1, this, and multiplied by k factorial multiplied by k factorial. And that's all for this question.